for the day is statistical methods for research. May I say that I will introduce Idrat later, but the agenda of the meeting for today is very simple. But it's not as simple because it will mean it will walk through a lot of steps, and it will not find time to take a deep breath and relax. What are the methods for quantitative analysis? What are the descriptive statistical methods? And how do you translate an application hypothesis to a statistical hypothesis? And I can tell you that these are all Latin to me. I'm that ignoramus with statistics are concerned. And
no problem,
a lot to be learned. I know you are a great teacher. A bit
Thanks
about the netiquettes, and then I will give a brief bio about Idrat Naqvi. G. Gohar, he's the manager, and he'll walk you through the netiquettes. Manager.
Hello.
CFT.
Hello, everyone. Thank you, Dr. Rukhsana. So basically, you are all requested to rename your Zoom accounts to the name of your university and then your name afterwards. Please note that you need to turn off your video so that you do not face any bandwidth issues, and you will be muted throughout the session except for the last 15 minutes. In fact, you'll be muted throughout the session. And please note that we'll have the question answer session at the last 15 minutes, and you can type your questions and we'll get back to you. And we turn on the polling once the session is completed. Before the question answer session, we turn on the polling for 2 minutes maximum. So you're all requested to please share your feedback, as it is very important for us. Thank you so much, Dr. Rukhsana. Please, over to you.
Thank you, Gohan. So, Idrat, you are a doctor, and if I must say, I am really impressed with the way you handle statistics. It is, gender is not related to maths, and there's a bias. Always they say, and statistics and number and computer sciences, but a lot of faculty like you at our campus belie that bias. We are very proud to have you. You have a PhD from the National College of Business Administration and Economics in Lahore. You have a master's degree from Sweden and also from the University of Punjab. You have more than 9 years of teaching experience at various higher education institutions. And if I may say, when you start talking, it's so difficult to grasp because statistics is tough. And just to add that there were more than 900 registrants for this session, 180 from FC, while there were 741 that were not from FC campus. But there were no responses received by FCC faculty. And I think the reason is because even going through your prior recording, I would be nonplussed because there's so much to understand and grasp. So Idrat, over to you. And what we'll do is we will take questions in the chat, and you may sort of stop after every theme or topic that you discuss to look at the questions, if there are any, and respond to that regarding that section of your talk. And of course, towards the end, we will launch the polling, and after the polling, if there are any more questions, once your presentation is over, then we will take the questions after the polling is done. So please be ready to poll within the last 10 minutes of the talk. Idrat, over to you. Thank you so much.
Okay. Thank you very much, Dr. Rukhsana, for such a nice introduction. Thanks a lot. So my dear participant, Assalamu alaikum. I am Dr. Idrat. I would like to tell you a very basic and brief, but try to give you some inward knowledge and tips about statistics and search methodology. Okay, I'm quite sure that all of you have heard about what is statistics. It's just having pretty good much and complicated definitions, but just you have to see that it converts the data into information. That's it. If it's data come from economic space or number, okay. Data has to be clarified by
Ithrat, you have not muted yourself, but we can't hear you. Somehow, I think the cord that you were connected to might have come loose, because you have not muted yourself. I see that.
I didn't.
Yeah.
Can you hear
Yeah,
me?
you're back on. You're back
Okay.
on.
So I think it's fine to take it like this. Now,
Yeah.
it seems to be, I was just telling you about, my dear participants, that you must be heard about statistics and very complicated definitions you have heard about it. I just give you a simple and brief idea about that. Statistics just converts the data into its information. And the main focus is on basically the data. Data, it can become from any stream, like it's biological data, it's economics-based data, it's business data, it's pure sciences data, like this, blah, blah, blah. So when you have essence of what, then it's going to be a good start. Data can be bifurcated into qualitative and quantitative, as you can see it over there, and must be have an idea about that. But when you got the idea, it's a qualitative or quantitative, what to do with that? We can do at least 3 analyses for them. Once it's known as univariate, then bivariate, and then it's going to be a multivariate analysis for that. Uni stands, it's quite clear. It's single variable analysis. It's going to be like, for example, you have collect a questionnaire for your research. Then it's a single question over there. What is your age? The age of the respondent. When you have an idea, the age is goes to the quantitative variable, then you can do its analysis. Or if you have it to be a categorical, it's from 10 to 20, 21 to 30, 31 to 40, and you just bifurcate into the categories, then you can delete like it by force to be a qualitative one. So do its univariate analysis means you have to take its graph and charts and can get some of sort its descriptive statistics, like its mean, averages, its dispersion, its variability, you can check it out, its proportion, if you are interested, you can do it. And by the means of chart and graphs mean like pie chart and the histogram, and you can see it all one by one. Bivariate is mean when we are simultaneously study 2 variables. And the very simple analysis for the bivariate, as a layman as well knows, is to be the correlation, to check the relationship between 2 variables. Then it's going to be the regression and blah, blah, blah. So many other things over there. And then going to be the multivariate analysis. We will emphasize basically today in our talk for the, excuse me, the hypothesis testing as well as the multivariate analysis as well, my dear, the regression. So firstly, a brief introduction again by the univariate, dealing with a single variable, graphically or numerically, it's going to be like a univariate analysis. How graphically you can interpret, like the pie chart, bar chart, histogram. As I told you that you have to bifurcate, it's going from the qualitative stream or quantitative stream. If it's the quantitative stream, then you can make it histogram. And if it's going for the qualitative stream, nominal or ordinal, then it's for pie chart or bar chart you can develop. And again, the descriptive statistics, you can get it. The bulk of the students you have it in your class, like the 50 or 100 or 150 students you have it for a journal course, then what will happen? You can represent them by a single numerical entity that is known as its descriptive statistics mean. And certainly it's very, when you have to calculate mean for the data, it depends on the nature of the distribution. If it's a skewed, so you have to take its median. If it's a more frequent values coming over there, like the polling over there, so mode can be, if you are interested in the positional values, so you can calculate its quantile, like the percentiles, deciles, and quartiles. You have seen most probably in the competitive exam, there are percentiles, not the mean. So that was the very reason, because you are interested into the particular position of the students within that particular group. So my dear, it's very to put the right descriptive on the right data set. Otherwise, it's a biased result will give it to you. Then you can check its variability, variance, and standard deviation, and so many other things, but it's quite simpler, which you have an idea about that. So it's a univariate analysis. The variable graphically and the numerically. Then it's going to be the bivariate things. Like the first and foremost, I told you, like correlation.
And again, the question comes, if we have the two quantitative variables, two qualitative variable, one is quantitative, one is qualitative, what to do? So I have just jotted down for yourself that if you are dealing with the two quantitative variables, quantitative, when I said, it seems to be like height and weight of the students, fine? So height and weight both are the quantitative and numerical measures. You can measure it on the number line from minus infinity plus infinity, the heights and the weights of the students. You can take each and every value. It's going to be the quantitative continuous, more specifically. So you have to calculate its Pearson correlation moment formula. And then the chi-square, when we have it like two qualitative variable, nominal to nominal, nominal to ordinal, or it's going to be the qualitative versus quantitative, so different streams. So we have to check the chi-square correlation association between them. And the third is going to be Spearman rank correlation. The third stream comes when we have rigidly two ordinal variables, like, okay, two ordinal variables, then we have to go to calculate its Spearman rank correlation. So these are the simple types, you can say, for checking the correlation: pure quantitative, pure qualitative, and the mixture of that. And now here, the next is going to be simple linear regression model. It's also can be turned into the multiple, but why we are saying it's going to be the simple? Because as I told you, we are telling you about the bivariate analysis, relationship between the two variables. Okay, we have no idea which kind of variables they are, means to say dependent variable or independent variable. As I given you the example of the heights and weights of the students, fine. So height and weight basically depending on something else, which is your age. So they are usually going to be dependent variable. But whenever we have no idea, one is dependent, one is independent, both are independent, both are dependent, don't go in such a debate. Even though for the nonsense things, for example, nonsense things like in a locality, you are seeing the number of crimes are increasing as well as the number of mosques. You would like to assess the relationship between them. These are two nonsense things, having no relation. But even though if you have the data set, you can check its relationship in them. And you are not going to consideration which is depending on which. They both can be independent, they both can be dependent, one can be independent, one can be dependent. You can check the relationship, the strength of association, you can check in between them. And when we have a clear-cut idea, one variable is dependent and one is independent, so it is better idea to fit a model on that, which is known as simple linear regression model. Here we have it, one is the dependent variable and one is going to be the independent variable. As an example, most probably you are a teacher or students over here from different universities. I welcome you all, my dear. And you have an idea that y like to be the marks of the students, fine, and x can be the time spent to the study. So we have a clear-cut idea that marks is depending on how much time a student he or she is spent for his or her studies. So marks is pretty good dependent variable, response variable on the independent variable time. So when you have an idea, so it is a better idea to analyze it not by just the correlation. You can check its correlation as well, but go for a pretty good model. It's over here. You can see it, as well as the testing of hypothesis. You can test it out with the hypothesis. And I think so you people, and I perceive that you have seen the pre-webinar material. Over there, I have told you about the testing tools, like the z-test, when to apply the t-test, in the proportion testing, I already told you. So my perception is that you have an idea about that. So I will just get rid about it and go to the hypothesis testing, which is just the slide have been provided, and you know the slides cannot talk with you. So I would like to talk with you about the hypothesis testing. So hypothesis seems to be like and certainly go back to the simple and multiple regression afterwards. So that was very basic. Before going to the hypothesis testing, if you would have any question or queries within the univariate and bivariate, you can ask, my dear.
I don't think there are any questions in the chat,
Okay.
But I do think that, you know, when you talk about different types of variations and you talk about nominal and ordinal, perhaps it would be good to give an example as you speak along for those terms. That will make it easy to understand, because many people do not know what is nominal and ordinal, and they should, frankly speaking, they should before coming to this session, but just to make it easy.
Yes, like my dear, it's quantitative seems to be like discrete and continuous. Fine, discrete like whole numbers, my siblings, my students in a class, like how many students is a countable data, like seems to be 15 students or 16 students. It's a whole number term, nothing in between them. There is a jumps in between them. And then continuous seems to be like take each and every value within the given interval. Like I was talking about the height. Height is seems to be from 5 to 6 can take infinite number. So quantitative can be for discrete and continuous, and qualitative can be for nominal and ordinal, usually for different streams. So nominal and ordinal, as I told you, it's tend towards for the categorical data. Categorical data means when you can make the categories of your data, like any sort of attribute. In my class, I can observe the gender of the students. It is a quality, but it does not matter. I will write male first or female first. I can write male first and count them, and I can write female first and count them. So I can make at least 2 categories for the gender. So it is sort of example for nominal. And ordinal seems to be when I am talking about the grades of the students. So grade like as A plus, then A minus, then B plus, then B minus. So particular order I have to follow it that. So it is going to be a categorical. How many students got A? It's going to be 90 students. How many students got B? It's going to be 2 students, like this. So when I'm talking about a particular order as well as the categories, so it's a ordinal data and categorical data, and in a broader sense, qualitative data. So qualitative can be usually for the nominal and ordinal, and quantitative for the discrete and continuous. Is it so? Now it's clear, ma'am?
Yes, absolutely.
Okay. Now talking about the hypothesis testing. Hypothesis is like, it's clear, it's an English word, hypothesize things, like assume. It can be my assumption, it can be my postulate, it can be my hypothesis, it can be a statement which may be true or may not be, because it's just can be a single person, single researcher claim, or claim by the quality assurance cell, or claim by somebody else. So we need to test it out. Is it true or not? With some statistical tools, we need to test them out. So there are particularly 7 steps. Before going to the 7th step, we have an idea what is hypothesis testing. For example, researcher in any field of study studied out a theory. That example is given over the college recruiters may claim that the average starting salary of the graduate of College of Liberal Arts and Science is less than. A particular college administrator is claiming that the liberal arts and science graduates' salary is less than the average starting salary of the graduates of the College of Engineering. So it is their claim. How they will justify it? With some sort of statistical testing, they can justify it. It's the recruiter claims which may or may not be true. So we need to test it, my dear. And we can formulate 2 sort of hypotheses over there. One is known as null hypothesis and one is known as alternative hypothesis. And usually the alternative hypothesis, which is symbolized by HA or H1. Yes, my dear, mute yourself, my dear. Thank you. Okay. So it's going to be like HA and H1 symbolizes for the alternative hypothesis. And usually it's going to be a researcher hypothesis, because it can give you one, sometimes it can give you a direction and it's more critical. Whereas that completely nullify your hypothesis is known to be the null hypothesis, and always usually having the equality. mu is equals to this, mu is greater than equals to this, mu is less than equals to this. Mu, when I said mu, it seems to be a average. You can test your average response, you can test your variations, you can test your proportions or the difference of them. So two kind of hypotheses we have to formulate. One is known to be the null and second is known to be the alternate of that. And it's the basic thing, very basic thing. When we are talking about the parameter, because in null hypothesis, we have to write the parameter entity. We will just, in the coming slide, it will clear to you what is how to formulate the null and alternative hypothesis.
Yeah, Itra, there was a question about null hypothesis, which I think you're explaining in the next slide, but there was also another, you're going to explain null hypothesis, right?
Yes.
Okay, because there was a question, but there was also an earlier question which I missed, that what are essential descriptive statistics that need to be mentioned for a good research article regarding medical sciences? Would you like to answer it at the end? We are okay with that.
Oh, I can answer it over there. As I told you, my dear, that if it's depend on qualitative stream, then we can report its simple percentages as well with the cross tabs. If it's going to be the quantitative one, I explain it very well that you can calculate its mean, its median. This is all the description of the data. Its variance, its standard error. So these are the descriptive statistics, as well as your descriptive statistics has to comply with your graph, like the pie chart. So the univariate is quite, and bivariate is, I think, so more than enough to report it, those things. Okay, so it is the sample and population things, because population goes to the parameter and parameter is the fixed quantity. When I said I have a class of 50 students and I do not want to miss any students, and I calculate the average response of that particular day from the students. I took a test. So it is going to be, for that particular day, it's going to be my parameter for that population, because I did not miss anyone. If I will take, just due to time and cost concern, yeah, I have just 10 minutes. Do I need to report to the higher ups how my class is responding? Just take 10 students out of them. So it's going to be like my sample, and sample can be varied. But if it's a true sample is if it's a representative sample, then it's going to be like give you the good results, certainly. And representative must be having more streams. It's a sampling stream, how to select a representative sample. But I can say it can be the 40% is a good representative sample of the entire population. So it's always a statistic quantity, sample quantity is always a varying quantity, sample quantity, whereas the parameter has to be a stick and fixed quantity for a particular population. Why I will telling you those things? Because in null hypothesis and alternative hypothesis, we have to formulate about the parameters. Means we are taking a sample, and along for the basis of the sample, we calculate all the things and draw the inference about the entire population, because we are quite certain that that sample has been developed or collected after so much effort. There is a sampling design working behind that. So basis of that design, we have to select a sample, and then on the basis of the sample, we need to jot down, try to reflect or inference about the entire population. So in a null and alternative hypothesis, we have to set the parameter entities. Parameter is the Greek letter, like this is mu, is the mean or average, is the mu1 and mu2 if you are having the two populations. I said the heights and weights, and is the proportion smoking and non-smoking, like the proportion for the qualitative data, and in some books you can see it for the pie. And if you have the two qualitative data and take the difference of them, so it's a P1 and P2, you can check its variability as well, which is known to be here, sigma square or standard deviation sigma. And one more thing, my dear, I need to clear it over there. You usually seen in the research paper that the standard error has to be reported, not the variability variance. Why so? Because standard error is basically having 2-3 very good qualities. It's report the answer in the same units as your data process, which the variance doesn't. It covers the entire data set and give you the average variability of the data set. So it's better to report your standard error rather than the variance. Please keep it in mind. Now, it's going to be the step 1. We have to set it out our hypothesis in that particular way. If you're setting, I said, this is my perception, this is my observation, there's the average height, mu stands for average now, the average height of this particular class is 5.5. I just set it out, this postulate, this assumption by myself. This is known to be mu naught, a general idea. Mu naught can be any specific value corresponding to mu. So in that way, you can set your H naught, number 1. If you have set rigidly the equality, then the complete, you can say, put the function completely deny it. It's not equals to. So it is the alternative of that. The researcher, the critical people said, no, whatever you're saying, it's not equals to. We need to test it out like that. So that's why I said it's a researcher hypothesis, but not equals to idea. It's not a good idea being a researcher, I have to tell you, because we are still blind after getting the conclusion. You just report that if you are accepting your H1, you're just reporting that mu is not equals to this. So what is the mu value particularly? Have no idea. So it's a non-directional hypothesis. The more directional hypothesis is like these two. When you're setting mu is greater than or equals to mu naught, I said on the average, the height of the students is greater than or equals to what? 5.6. And the possible alternate, because you see, you're observing the all state we are covering over here, greater than, less than, equals to. So we have to make all the streams over here. Same here, by saying not equals to, we are covering the both edge, greater than and equals to, but still not clear in that. So that's why I said it's a blind hypothesis, alternative. In that sense, this H1 is a directional hypothesis. When you're accepting it, that mu is going to be lesser than 5.6. So you're giving it direction. Okay, all students having the height on the average, less than 5.6. And similar the stance over here. If you're setting out your null hypothesis or the researcher hypothesis like this, greater, so the phenomenon which is completely nullified, it has to be lesser than and equals to. So in that way, my dear, you can set it out your null and alternative hypothesis. These are the three possibilities. And there are certainly the more sophistications in the probability terms you can do it. And this is beyond of this lecture. People will be confused with that. I'm just telling you about the average stance. So in the similar way, you can set it out for your variability, for your difference between the means, for the difference between the proportions, and likewise the null and alternative hypothesis. The second step is going to be think about the level of significance, which is basically an error. And a pretty good example is for that. For example, there's a court trial going on and the judge commit, the evidence come against a person who seems to be not guilty. Why we are saying guilty? Because the, you can say, evidences are come against him. If the evidences are come against him, so judge can take the decision that, yeah, he is a guilty and punish him. So how many times judge can take such errors? Maybe 1% of entire of his cases he dealing, maybe 5%, maybe 10%. If beyond that, being a statistician, we have put the limit. If beyond that, so check it out, there is a problem in the judge. So he's not taking the right decisions every time. It seems to be like these are the prior probabilities of risk which we have to be developed. Like in a simple way, I said, a student is a very good student. Being a teacher, I can assess. He or she spent a lot of time for the studies. His IQ level is very excellent. Teacher-student interaction is going to be very well. But at the time of final examination or the final presentation, he or she got sick and did not human beings. So what we can do, rejecting H naught, given H naught is true, we are rejecting the true phenomenon, but not all the time we are rejecting, my dear. It's maximum going to be 10%, it's maximum going to be 5%, it's maximum going to be 1%. So when it's going to be 10%, so it's mean we are 90% confident in the work what we have done. So alpha is going to be priorly set and error knows to be a type 1 error probability, which is not to be larger than usually 10%. Fine. And starting from 1% to 10%. It can be lie between then, you can set it out. But by default in computer software, there are 5% stance has to be set it out and 95% you are confident in that. Then it's going to be to decide about the test statistics, which test has to be applied. It's to be a Z or T. And by default in the softwares, like we will be seeing that where today for R, it's set it out by T statistics, not the Z. Why so? Because T is coming from Z basically. How? For taking a sample size of T statistics, we have a prior assumption that the data come from the normal distribution, and Z, you have an idea, Z stands for the normal distribution. But my dear, you do not need to worry about it. We have to learn these particular formulas. It's already built-in functions of the computer. So you do not need to worry about such things. Just to know when to apply. You see, there are two streams, sample size and population variance need to be considered. Population variance known, sample size has to be large. Yes, I want to make it clear. Large sample in statistics means to be larger than 30. A small sample considered to be in statistics language less than 30. So in all stream you are seeing Z, Z, Z. Just the one stream is crucial one. Sigma is unknown, population variability is unknown, and the sample size is less than 30. So when sigma is unknown, and which is usually unknown, जो नहीं हमें पता होता parameter, and sample size is going to be less than 30, then we are more emphasized on T. So T is more crucial. And when sigma is known and sample size is greater, so in all rest of the things, it's going to give you the same results. So we are not worried about it. Basically, when you have a large sample, so T or Z may, there is no distinction between them. It's going to give you the same results. So that's why the built-in function in the sophisticated languages now coming through for the T statistics, because this is the crucial state when n is less than 30 and sigma is unknown. Very important criteria, my dear. Critical region, how to decide. Now, we formulated and calculate the values, and on one click, you get the answers. Get it? Okay. Then after that, you have to select if the p-value, where is the p-value? From with the help of this alpha. We need to compare the prior error with the probability. It is already generated in your outputs. You have to force your observe just this thing. If the probability value or the p-value is going to be less than alpha. Alpha, for example, you have set it out 0.05. So if it's going to be less than alpha, then you have to accept your alternative hypothesis. Otherwise, you need to accept your null hypothesis. Means otherwise का मतलब it's greater than 0.05 से बड़ी है, so you need to accept your H0. 0.05 से छोटी है, so you need to accept your H1 या HA alternative hypothesis. I think so it's going to be clear. And this is the tabulated value जो हम before using the software we have to gone through, but you do not need to worry about it. The decision will be same with the p-value, and nowadays I think so it's more sophisticated. But still, if you have any problem or question about that, more than welcome. We will certainly here to help you out, my dear. And these are the particular values which you can learn it by heart, or you can calculate it even though from the normal distribution table. Do not worry again, because it's a built-in functions in the R. So any question in hypothesis testing, then my dear, I will go for the hands-on regression. There are so many questions, I think. Okay. Yes, I have already addressed this question. Yes. Okay, it's 22 chats over there. What the people said. Nothing else. Okay. Okay. So, my dear, I would like to share one more screen with you. Do you have an idea about the R, dear participant? You can see this, the interface of the R. And I have already shared the slides of the simple linear regression code and multiple linear regression code. I will just run it for you. Fine. So, and we will discuss the interpretation, which is basically crucial to explain. Okay. So my dear, it's over there. I will firstly tell you about the I will share firstly, my dear, these slides for, yes, share screen. Just give me a moment to share your slide here. Yes, these slides have already shared with you people. Is it so now? That we have to observe the yield of the gain, why we are tending towards. As I promised to you that after the hypothesis testing, I will give you the hand-on session on R. So that's why we are coming over there. This is the hands-on session. If you have an R, you can open it. I can give you 2 minutes before that. So you can do open your R, my dear, interface and do it simultaneously along with me because you have the slides as well. So in the same slides, which I have already provided to you, we are talking about the fertilizers and the grains. And it's quite clear that the yield, grains yield, the output is certainly depending on the amount of fertilizers. So here in this example, we have a clear-cut idea, which is the independent variable and which is the dependent variable. So what we can do with that? We can check even its correlation. We can check its scatter plot to see the trend, which we will do it certainly. So I will again share with the interface of R with you, my dear. Like this. Can you people see the R interface?
Yes, ma'am, it's visible.
Okay, ji. So this is the same very data set. How you can put it, just for your sake, I can. Like you can give the name. There was the fertilizer and the yield. You can give the same name, or for your ease, you can give them X and Y. X and usually going for independent variable and Y is for dependent variable. So how we can put it, like the X and it's a greater sign and then a hyphen, and C for combining, and then the small parenthesis, and you can write it out whatever you want, like this, and blah, blah, blah. So this is an example. This is the syntax to write and store your variables into the R interface. And then the semicolon is also the part of the syntax. You have to terminate this command. So I just copied it down for you. And what to do? Now, we have to put the simple linear regression model on that. Before that, we can check its correlation. For the correlation, most probably you have an idea, the score command. And one more thing, both the yield and the amount of fertilizer are quantitative. And as I told you, for the quantitative variable, the correlation can be checked by Pearson product movement correlation. So it's by core command X, Y. You can check its correlation and just run it out, all these commands like this. You see in the output window, it's going to be blue. So blue meant for it's going very well. There is nothing to be disturbing to the interface. So now here we got it 0.9577967. What this number figure it out for us? It said because the correlation having this Pearson correlation having the range between -1 to +1. And if it's going to nears to -1, it's meant for the two variables are highly negatively correlated. And if it's going to be the value going to be nears to 1 +1, it's said to us the highly positively correlated. And this is sensible thing than the fertilizer as well as the amount of yield has to be highly correlated. So here you are seeing 0.96 approximately. That is 96. There is a great sense of strength. So is it complying with our, you can say, plot command? So by simple writing plot, you can check it out. It's scatter plot. That's it. See it over there, left, right side. You can see it here. Actually, we have a lesser data set, so it seems to be like this. When you have a greater data set, it's more visible. But still, it's complying with our answer that the correlation get 0.95, which is quite near to 1, even though with such a smaller data set. And the straight line is over here. You see, it's a straight line trend over here. So, plot, it's a scatter plot, mean when we do not need to join. But even though we can get a hypothetical line in them, we can see a line, my dear, as well. So the purpose is to fit the model. For model fitting, you can write like this: linear model. LM is the command fitting the model. Y is the response variable. This is the tilde sign, which is quite near to your number line on the top left side. You can take this tilde sign with the shift and tilde. Fine. I can take it for you like this. Fit is the storing operator. And then this is LM, going to be Y, shift ke saath. This is like tilde is like alif madda. It's quite near to your number line on X. And that way you can get your command. So after giving it, you can run it and you can see what will happen. Nothing is going over here, but it's blue still because we have stored it out. हमने सिर्फ store किया उसे fit में. When we call it by store, so the answer is over there. The coefficient and the X value corresponding to that. See, it's going to be intercept value and the X value. What about that? What is this intercept value and this? Just store it out. We will discuss it just after a moment, after getting it out. I will show you, my dear. Just keep it in mind. This is 31.5905 and 0.3771. Okay, remember these values. I will show it out how you can interpret it, my dear. And it's here, the slides I've already showed with you. Like this. Basically, this is the model which I was talking with you, that when you have a pretty good idea about the response variable, the dependent variable, and the independent variable, okay, the yield is depending on the amount of fertilizer. And now you got the estimators in terms of this. This is the 31.5905 plus 0.3771x. This is the intercept. You might be heard about the slope of the line equation in class standard 8 or 9 or maximum 10 standard, I think, right? Which was mx plus c. So what was the mx was there? M was the slope of the line, which is as complying as this 0.3771. And what was the c? The intercept. Intercept is over here, which was the constant quantity. On the average, the y is depending on that. When your x, the explanatory variable, is going to be 0. So we are not interested into the intercept. It is over there. It can be negative. It can be positive. It is over there. It's a fixed amount, has to be followed up, where the line cut is the y-axis. And we are much interested in the regression terms in this slope, which meant for that a unit increase into the independent variable. On the average, the response variable will be increased by 0.3771 units. I will repeat it, that we are much interested into this slope because due to this slope, these two variables are basically having the relationship of dependency and independence. Like with the unit increase into the independent variable, your independent variable was the amount of fertilizer. On the average, why I'm saying on the average, this is y hat is tending towards the expected value of y. Expected value meant for average value, not talking about the single value. It's on the average, giving you the stance that on the average, the response variable is depend on your independent variable by that much unit, right? And if there is a negative sign coming over there, it can be possibility, like your price and demand relation is a negative relation. So it's going to be the negative intercept over there, sorry, slope, negative slope over there. So you may interpret on the average, there is a decrement, not the increment. In this case, there is an increment. And whenever you get the negative slope, you can say it's a decrement in that. So I think it's clear here. So this is the same interpretation which I've already provided to you. Now I think it's a clear that it's y hat is going to be independent. It's fine. Any question till that, G? No? Okay, so carry on. Uh-oh. Sorry, I think so. Stop share, man. Our studio interface, my dear. So now we have for the multiple regression, but the 15 minutes are left. So I think it's better if you may ask the questions so we can wind it up our session, my dear. The one important thing for the multiple regression is left it. I will just within few seconds, just put in the data and get the result for you people, that you have an idea how to get through with that. So it's over there. I have just copied down the data from my, you can call the data as well, but certainly we need one more session, how we can call the data and how for the other things, so many other things over there. Now we have the multiple sort of data, means to say sale price is depending on the land value, improvement value, and area. There are now three variables, which seems to be the independent variables. And now one is the dependent variable. Going to be the putting multiple linear regression on that. And you see, having no problem over there. Very important thing is over there, you can see it in the output. It's like this. You got the coefficient, like I have shown you the beta naught hat. Now, with corresponding to each x, what is x here? This is land value, x1, improvement value, x2, area, x3. So corresponding to each x, you have it, it's the slope. So it's going to be land value slope, it's going to be improvement value slope, and it's going to be the area value slope. Beta naught, beta 1 hat, beta 2 hat, beta 3 hat, and it's going to be beta naught hat. Now you can get the summary statistics. Summary of what? For the fitted regression line, you can get the summary of that. Wow, pretty good answer we can have it over here. Nothing to be done with by ourselves. That is the p-value which I was talking about. This is over here. You see, we are not interested, as I told you, the intercept. We are interested in the independent variables, and the criteria. What we have set it out. The criteria was if the p-value is greater than 0.05. So what to do? To reject your null hypothesis. And if the p-value is less than 0.05, so accept your alternative hypothesis. So see, the land value is not having much influence on your response variable. So you can omit this variable. As well as here, the area is not. But my dear, firstly, do not omit these two simultaneously, just one. The land value, we can omit this variable and see what will happen. It's going to be like this. We have to run it again. Yeah, here we go. See, it's already improved. Area was beforehand, I can show you here. Priorly, it was 0.05, approximately 0.06, which is greater than 0.05. So seems to be you can reject your H naught and you, sorry, H1, and you have to accept your H naught. Means that area is not contributing and Means to say, for the next researcher for the similar problem, you have interpreted that just use the improvement value and area for that particular problem and you can get the pretty good result. So many other things. It's adjusted R scale, I can tell you, and very much things, but it's better to ask some questions. So I would like to stop sharing here and we can discuss some things if you want, because
we'll be sharing the polling as well for 2 minutes. You're all requested to please share your feedback. Thank you.
yes, it is very important. It's going to be feedback, so that's why I stop it over there. Yes, meanwhile, we can discuss that somebody was asking the question that it is important to check the underlying assumption. Yes, my dear. For example, because we need a separate session for that, if we would like to test the assumptions. Normality assumption is the first and foremost assumption. Means we said when we are talking about the regression, so we have a pretty good idea that regression is applicable when the response variable, the Y variable, has to be a quantitative continuous and following the normal distribution, because the entire theory is based on that. So we have to check its normality assumption. We have to check there is a correlation between the response variable and the independent variable. Yes. And the homoscedasticity means equal variances assumption. We are supposing it out that on the average is having the mean is 0 and the variability is same. So we need to test it out, these assumptions. Otherwise, you will get the biased result, obviously. Yes, my dear, F statistics is going to be for the variability. Whenever they say we have tested out, okay, we want to test the mean. So I told you that the Z statistics or the T statistics is the built-in functions. You do not need to worry now. If you would like to test your variability variances, then you have to apply the F statistics. And the T, for the proportion testing, you have to test your Z statistics. If you go through the recorded material now, in which I have already put it some examples for the proportion, single proportion, double proportion, and for the single T test and the double I think so as well. So it's over there. You can check it out, already provided pre-webinar material. Just go through with that. You can, my dear, get an idea about that. With sampling? Where is that? I didn't see. Can I see it as well, chat? Yeah. Yes. It's for UOI, Dr. Ghulam Abbas. Different sample can be taken from population. So the characteristics of sample data will be changed. So does the hypothesis test results? Please comment. Yes. Yes, sir. As I told you that Dr. Ghulam Abbas, when you are taking the sample, so there is a sampling design. And there are 4 streams: simple random sampling karni hai, stratified karni hai, cluster karni hai, systematic karni hai, and much more pretty good things over there. So we have to select a sample based on some design. or you said, nahi yaar, research mein time nahi hai, time and constraint. So you can go for the convenient sampling as well. But if you go for the pretty good design, then certainly you get the good results. So I do prefer, and certainly it's varied. So you have an idea priorly. What is your objective? You are going for what? You are selecting the quantitative data, means starting from the data domain, which kind of data I am taking it out, and which tools I need to apply. If this is going to be from qualitative stream, like I'm interested in how many educated from abroad, how many are smokers over there, and this seems to be like proportion, qualitative one things. So there are some other things for them, like you have to go for a chi-square test for association, you have to go for the bivariate association, you have to go for a Spearman rank correlation, you have to go for logistic regression for that, multivariate analysis. And because your response variable is going to be now qualitative, if the response variable is going to be qualitative, binary qualitative, yes, no starts, then you need to model the probabilities rather than to average it out. So it's drastically different streams for that. So we have to start from the scratch, which kind of data set we are taking it out and which are the appropriate measures. So I do suggest it is very good to do hard work and do it all the things by yourself, but take a consultation by a statistician as well. So maybe they will put you in the right direction. That's my humble request. Thank you very much. No, my dear, it's like if you are starting a very sensitive issue like the life and death threat over there, so we can reduce. And some of the biological studies, when the life is on the stake, so it can be 0.01 even though %. Certainly we don't want a single entity be ki death ho. So that's why we can reduce it. I was giving you just the broader idea that it's a built-in function for the 5% and 95% we are confident. So certainly if you are, yes, you can reduce it or you can, but not to be increased by 10%. If you are increasing it by 10% in some sort of studies, then it seems to be your power of the test has to be reduced over there. It's directly related to the power, na? So it will be decreased your power. Or another way you can say, if you are decreasing your alpha, so you are increasing the risk of the beta, which is more dangerous over there. So we don't want, because jitna beta increase hoga, the power will be certainly decrease it down. So for the moderate testing, we choose it out for 5%, that we are 95% confident. Significance of test mean if you are using, priorly you have an idea, if I'm using the averages, so I have to use the Z or T, fine. Then the variable which are included over there, that is needs to be significant. In terms of variable, and certainly it's, the criteria goes to the p-value. So we have to observe its corresponding p-value, what's it's going on over there. If the p-value, the same criteria which I haven't explained, my dear. So it's terms of variable, we have to see it afterwards. It's primarily we need to decide which test to be applied. So if you are applying the wrong test, certainly it's going to be the wrong significance for that test.
So that's pretty much it. Thank you so much, Dr. Itra, for taking out your valuable time and conducting an insightful session. And thank you to the participants, both FCCU and non-FCCU. We'll conclude here. Please note that we'll be sending out the material and the video within 2 to 3 working days. And that's it. Thank you so much all for joining.
Okay, somebody was asking the question. I can give the answer in by mail. If Dr. Muhammad Usman, you can send me the mail so I can let you about that. It's a sophisticated software over there. So you are talking about the mixed models. So we can discuss it afterwards. Thank you so very much. Thank you, everyone.
Thank you.